Hello again. We're doing the ACT math practice test from 2015 and 2016. Today we're going to be going over numbers 21 through 25, just talking about the problem, how to do the problem, how you should do the problem on the ACT test, and also whether or not you should skip the problem and come back to it. And finally, if you should use the calculator immediately or not, because sometimes using the calculator does take you longer than if you just did it by hand. So here we go. To get a driver's license, an applicant must pass a written test and a driving test. Past records show that 80% of the applicants pass the written test and 60% of those who have passed the written test pass the driving test. Based on these figures, how many applicants in a random group of 1,000 applicants would you expect to get driver's licenses? All right, so right off the bat, we know there's 1,000 of them. We know 80% will pass the written test. Well, you know automatically that's 800, but not all the ones who pass that will pass the other part of the test, so you can go ahead and eliminate that last choice right there. But this is going to be a simple probability problem. I would use the calculator off the bat. I do 1,000 applicants times 80% of those. Okay, and then that times 60% of those who have passed the written test pass the driving test. So that times 60%, and I get my answer, which is 480. Okay, so that's this selection right there. Not too bad. All right, if a, b, and c are positive integers, such that a to the b power is equal to x and c to the b power is equal to y, then x times y equals blank. All right, so I would go ahead and write this one out with substitution. So if a to the b power is x, that means we have a to the b power times y, which is c to the b power. All right, so without thinking about the concepts here, if you can just remember the procedures, this is the same thing as a times c raised to the b power. All right, maybe I can do a concept video later on talking about exponents and things like that. Next, which of the following expressions is equivalent to 1/2 y squared times 6x plus 2y plus 12x minus 2y? All right, so the very first thing you should do for this one is to combine any like terms on the inside that you see. So 2y and negative 2y cancel each other out, and then 6x plus 12x gives me 18x. All right, and I want to multiply that by 1/2 times y squared. So I multiply the number times the number, and I get 9. And then since these things are not the same variable, we can't combine them in any way, so it's just going to be times x times y squared, which is A. An artist makes a profit of 500p minus p squared dollars from selling p paintings. What is the fewest number of paintings the artist can sell to make a profit of at least $60,000? All right, so there's a few different ways to do this, a few ways by hand. The calculator is the easiest way, and there are several ways to do this in the calculator as well. What I would do is I would go to y equals, and I would type in my profit equation there. So we've got 500. Now I can't use p, I'm going to use x minus x squared. And not 8x. My calculator is running from me. All right. So I've got my equation into y1. Now I'm going to adjust my window to where I start at the smallest number in my answer choices. And then the change in my table is going to be to where I can see all my answer choices. So I'm going to let that be 50. And now I'm going to look at my table. So second graph looks at my table. Okay, we want to know where it's at least 60,000. So when I'm scrolling down, I notice that 60,000 is the value when x is 300. So that's going to be my answer right there. Last month, Lucy had total expenditures of $900. The pie chart below breaks down these expenditures by category. The category in which Lucy's expenditures were greatest is what percent of her total expenditures to the nearest 1%. So this is asking a couple of different things. We want to know the category in which Lucy's expenditures were the greatest. All right, so that's going to be clothes, because that's the biggest number. Is what percent of her total expenditures to the nearest 1%. So they were nice enough to go ahead and add all these up for us. So we just have to take the amount she spent on clothes and divide it by the total amount she spent total. I guess that's redundant. The total amount she spent. There we go. And we get 28%. All right, and that is it. That is these 5 problems. I hope it's been helpful. We did 5 problems in roughly a minute each. So good luck on the test. Good luck studying. Have a good one.